Bismillah. Assalamu alaikum. Hello, everyone. This is Dr. Gamal from your channel Think Math, and welcome to a new lesson about basic functions and their graphs. Today, we are going to talk about the representation, graphical representation of some of the basic functions that we use frequently in math, and how do their graphs look like. First, let's talk about the constant function. The constant function is any function of the form uh, f of x equals a, where a is a constant. So, for example, if we have here f of x equals 5, the constant is equal to 5, and this function is a constant function, meaning that regardless of the value of x, the value of f of x would be the same all over the domain. So in our case here, a is equal to 5. So f of x is equal to 5 means that will always be equal to 5, or in general, y is going to be equal to the constant that of the function. Okay, so a. Okay, so here, for example, when we have y is equal to 5, this means that regardless of the value of x. So for example, when x is equal to negative 25, y is equal to 5. When x is equal to negative 10, y is equal to 5. When x is equal to 0, the same is equal to 5. And when x is equal to 20, it is also 5. So if we plot this, if we connect all these lines, then we get a straight line, a horizontal straight line parallel to the x-axis, and it cuts the y-axis at the value y equals 5. Okay, now if we switch to the linear function, the linear function is one of the very famous functions because it's called linear because it's represented by a straight line. The function is f of any function of the form f of x equals ax plus b is called a linear function, and it is a first degree function because the maximum exponent of x is equal to 1, and here a cannot be equal to 0, because if it is equal to 0 we will go back to the constant function. So the most basic form of this function is f of x is equal to x, or when a is equal to 1 and b is equal to 0. So this function, when f of x equals x, can be represented by this graph, and we have here, for example, we are representing some of the values of the function. To plot it, we are using this table. For example, when x is equal to negative 3, f of x is equal to negative 3 as well. So we put a point here. When x is equal to negative 2, f of x is equal to negative 2, and when x is equal to negative 1, y is equal to negative 1, and when x is equal to 0, and so on. And then if we connect all these lines, we get a straight line. So the form that we used here for the equation of the straight line, y equals ax plus b, is called the slope-intercept form, because a is the slope, or the coefficient of x here is the slope of the line, and b is the y-intercept, and as we see here, the slope is equal to 1 and the y-intercept is equal to 0. If we take another form of the linear equation, where the equation is 2x plus f of x is equal to 2x plus 2. If we substitute for the values here, 2 times negative 3 is negative 6, plus 2 it's negative 4. For x is equal to 2, 2 times negative 2 is negative 4, so f of x is equal to negative 2, and so on. So we substitute for this value, we mark these points on the graph. So for negative 3, 1, 2, 3, it's negative 4 here, 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 and here. If you connect all these lines, we get a straight line. Looks like that. Okay, so this point is wrong. It should be here. This point. Yeah. Okay. So this line is the slope of this line is 2, and its y-intercept is 2 as well. When x is equal to 0, y equals 2. Now let's talk about the quadratic function. So the quadratic function is any function of the form f of x equals ax squared plus bx plus c, where a is not equal to 0. So uh, when you have a function of this form, its graph will look like a parabola, and if a is greater than 0, then the parabola will look upwards, and if a is less than 0, the parabola will look downwards. Now, the simplest form of the quadratic equation is when a equals 1 and both b equals c, and they are both equal to 0. So if we look at the table, we are taking a sample of some of the x values. So when an x is equal to -3, y is equal to 9, y is equal to x squared, so x is here. When x is equal to -2, y is equal to 4, so it's, and for 1 it is 1 here, for 0, 0, it's 0. For 2, for 1 it's 1 again, then for 2 it's 4 again, and for 3 it's 9 again. And we can see that this is a curve symmetric about the y-axis, and it's an even function because f of -x is equal to f of x. And you can check the full lesson about even and odd functions in the playlist in the description. Now if we look at another form of a quadratic function where there is a constant added to the x squared, so it will look like a parabola as well, but it will shift vertically upwards, and we will see this. Okay, for -3 it is equal to 11 when we sketch it. If we substitute x squared, which is 9, plus 11 plus 2 is 11. For -2, x squared is 4, plus 2 is 6, and so let's substitute for these values. 3, 11. Okay, and for 2 it's 6. For 1 it is 3. For 0 it's 2, and then since this is an even function and symmetric about the y-axis, as we explained in the even and odd functions video that you can check in the playlist that will appear in the description, and it will look like a parabola facing upwards like that, but shifted by this amount upwards. Now if we go to the absolute value function, which is here it has the form of f of x is equal to x when x is greater than 0, and -x when x is less than 0. So if we plot this function, so f of -3 is 3, f of -2 is 2, and f of -1 is 1, f of 0 is 0, and so on. So if we plot it like 1, 2, 3, 3, okay, it will have a V-shaped graph like that, passing through, and it's an even function symmetric about the x-axis, about the y-axis. And if we extend the lines in both directions like that, it will look like this. Okay. Now if you look at the cubic function, the cubic function is one of the basic functions. The cubic function is any function of the form f of x. This one here is the most basic form of it, but in general, any cubic function is any function of the form f of x equals ax cubed plus bx squared plus cx plus d, and a is not equal to 0. The most basic form of it is when x is equal, f of x is equal to x cubed. So if we substitute for some values, for example, when x is equal to negative 3, its cube is going to be equal to negative 7, so it will be almost here. If when x is equal to negative 2, its cube is negative 8, which is here. For 1, for negative 1, it's negative 1. For 1, it's 1. For 2, it's 8. And for 3, it's 27. So, and this is an odd function. So it is it's an odd function, symmetric about the origin, and it is where because f of negative x is equal to negative f of x. Okay. So if we go to the final function that we are going to talk about, which is the reciprocal function. So the reciprocal function is an interesting function where, for example, its most basic form is f of x is equal to 1 over x. So if we take some values, for example, when x is equal to negative 10, its y value, or f of x is going to be equal to negative 0.1. So this is here. When f of x is equal to negative 5, when x is equal to negative 5, f of x is equal to negative 0.2 here. When f of x is equal to negative 2, x is equal to negative half. And let's add some values here. For example, when x is equal to negative half, f of x is going to be equal to negative 2. And when x was equal to negative 1 over 5, f of x is equal to negative 5. And the same for the odds, the opposite, the negative values of these numbers. When x is equal to half, f of x is equal to 2. When x is equal to 1 over 5, f of x is equal to 5. Okay, so we are completing the table to adding new values. So let's plot for, okay, when negative 2, and in 1 it's here. It's negative negative here, half is here, and so it would look like this, and on the other side it would look like that. So it has an asymptote at a horizontal asymptote with the x-axis in both directions, and a vertical asymptote with the y-axis, and it is undefined at x equals 0. Well, that's it for today's lesson. I hope that you have benefited from it, and you have understood and learned new things. And if you have any questions or comments, please leave them in the comments section below, and check our previous videos for more math lessons. And if you need any specialized or personalized help in math, please check the links in the description, and see you next time. Bye.